All right, so notice I have two equations here, and I want you to write the following in standard form and to also graph them. So the first thing I see in this first example right over here is that that is not in standard form, because in order to be in standard form, my x and y have to be on the same side. So clearly my x is on one side of the equation and my y is on the other. Now, which one should I move over? Depends on your x. Your x is really what tells you where that x and y belongs, because your x has to be positive. Notice that it is currently positive where it stands. So that tells me that I need to move my y over. Now, what do I mean by mathematically moving my y? Is I'm going to do the opposite on both sides of where my current y is, so that way I can, mathematically move it over. That's a positive 3y, so I'm going to minus 3y on both sides. I'm going to end up with x minus 3y is equal to a positive 9. Now you can see here that my x and y are on the same side. My x specifically is positive, and my constant's already on the other side. So just like that, I can see that this is currently in standard form. On the test, I'm going to tell you to identify your a, b, and c. Your a is the coefficient in front of the x, which in this situation is the 1 because nothing's written there, right? We only have one x. Your b is going to be the coefficient in front of the y, which is a negative 3. And your c is going to be whatever the constant is on the other side, which in this situation is a positive 9. So that alone is a 4-point problem on the test. If you can show that you know how to do this, you're going to be golden. The second half of your points is going to be whether you know how to graph it. Now remember, standard form is super, super nice to graph if you remember one key concept. Now let me show you what that is. Now notice that I am changing colors to kind of just show you that I'm switching a kind of a mindset. I know how to change something to standard form. Now I'm graphing it. So I'm technically doing two different skills here. Now this is my standard form. For lack of room, I'm going to write it over here if it's okay with you guys. Okay, so ignore this for now. I'm going to write my equation to kind of show you how to graph them. So that's my standard form equation to number 1. Remember that you only need 2 points in order to draw a line or to graph a line. So what 2 points should we choose? Now, if you remember yesterday, we practiced this all yesterday. We learned, or we pretty much reviewed, that if you plug in a 0, zeros are really easy to use, especially if you're using them with standard form. So plug a 0 in for the x and solve for y. Plug a 0 in for the y and solve for x. Go on from there, okay? Let me show you what this looks like by changing colors here. I'm going to start off with finding my y when my x is 0. So notice that this is x minus 3. X minus 3y is equal to 9. So that means that 0 minus 3y is equal to 9. And notice that the 0 pretty much cancels out because anything plus or minus 0 is just itself. So I'm left with the negative 3y. Dividing by negative 3 on both sides, you finally end up with y is equal to a negative 3. You can see that it works out pretty comfortably, right? Or pretty, how would I say, smooth. All right, now let's go ahead and plug a 0 in for the y and solve for x. Well, here's my y, so that means that x minus 3 times 0 is equal to 9. Notice that negative 3 times 0 is 0. You're left with x equals 9. Nothing really to solve for. You're just left with that 9 there. So just like that, you just gotta make sure that you make the connection and understanding that you can really choose whatever value you want, but why make it harder on yourself? Choose 0 for x, choose 0 for y. So that way you choose those specific points, and they're nice because they show you your x and y intercept. 0 and negative 3 can be located right down here. 9, 0 is located right over here, and you only need 2 points. Now, one thing I want to make sure that I'm clear about, that this is all the work for number 1. I know I kind of skipped around the graph, but it was just because it was closer to me. Okay, cool. All right, I'm about to erase this. Does everybody have a chance to maybe write down as much as they need? And if not, remember that video is going to be over here anyway to help you out as well. All right, so if you look at this example, it is almost in standard form. My x and y are on the same side. My x is positive, but do I have integers for coefficients? No, so it's your job to fix that. Let's start it by remembering our concepts on how to get rid of fractions. Now notice that this is divided by 3, because this 1 is divided by 3. How do you get rid of division by 3? What's the opposite? Times by 3. So notice I put the left side and the right side in parentheses to kind of remind myself, hey, you're distributing within everything on both sides. So I'm going to go ahead and multiply everything by 3. So what's 3 times 1/3? Well, notice that you're dividing by 3 and you're multiplying by 3. So the 3's cancel out. Notice you're left with a single x. Same thing happens when you distribute it to the second 1/3. You're just left with a single y, specifically a negative y because we had a negative there. And then 3 times a negative 2 is a negative 6. So just like that, you notice that this one was a little more straightforward. if you got that concept down of getting rid of fractions in terms of the whole equation. And then now you can go ahead and find your x and y point. Just for lack of time, I'm going to do this a little bit more quickly. Notice I'm plugging a 0 in for the y. If you see me cover it with my hand, notice you're left with the negative y. Dividing by -1 on both sides, you end up with a -6. Now, if you plug a 0 in for the y, that cancels out. Notice you're also left with the -6 over there. Oh, I noticed I made a mistake. Notice I left with the -y, right? What do you have to do to get rid of that -1? Divide by -1, right? So notice that this y would change into a +6. I believe I made a mistake there. That's what happens when you rush. Make sure you're taking your time. It's always one of those things, especially when you're on a test, that you hustle through things, you make those little simple mistakes. So do as I say, not as I do. 0 and 6 can be located right over here. 1, 2, 3, 4, 5, 6. And then -6 and 0. 1, 2, 3, 4, 5, 6. And that's it. This would probably be a 5-pointer. One for changing it to standard form by doing the fractions, identifying your A, B, and C, and then also graphing it. So make sure that you got this down, because it's going to be worth quite a bit of points on your guys' upcoming exam. All right, guys. So one thing I want to kind of make sure that you guys understand, that you guys experience slope all your guys' mathematical careers, but you've also experienced rate of changes. Now, a rate of change literally is just measures how much a quantity changes relative to change in another quantity. So what I'm trying to drive home here is that a rate of change is the average change between two quantities. Now, can someone think of a rate of change that you guys use in everyday life? I'll tell you a hint: when you're driving, your speed, because when you go how fast, what is the change there? Or what do you usually get at? Miles per hour. So if you notice here, miles per hour, that is a rate of change, because you're taking the average rate of change between how much miles you travel and how much hours you travel. Can anybody think of another one?
Like temperature when you're heating the coffee.
That'd be temperature. What would it be, like heat per minute type of thing?
Yeah.
What would be the two quantities? I guess so. Yeah, that'd be a good one. I know a popular one that I know a lot of students use. WPM. Has anyone taken a digital class yet? Typing class? Freshman year, right? Words per minute. Yeah. So when you're typing, you're really just finding the rate of change of how many words you type per each minute. So this is just rate of changes. It's the change, our change between two different quantities. Now, slope is a rate of change. It's the average rate of change in the y coordinates corresponding to the x coordinates. So we're going to do a bunch of activities just to make sure you understand that completely. That it's just a rate of change between the y's and the x's. Now, it might look different the way I present it to you, but you're doing the same thing. You're finding the average rate between those two things. So let's start talking about this here, just kind of like a basic kind of remembering of what is slope, what does it look like as a graph and a point and so forth. So let's say that I want to find the slope of a graph or through two random points. And suppose that those 2 points are x1, y1, and x2, y2. Well, keep in mind that these are just variables, they're just randomly everywhere. But I want to kind of show you how you're literally just finding the rate of change of two different things. Let me show you what that looks like. If I have two random points, what I like to call in space. Notice this graph, there's no positioning. I'm just going to put the point right over here. Let's call that x1, y1. And let's graph our second point. I'm going to put it in a different color so that way you can see it a little bit more randomly. And I'm going to call that one x2, y2. Remember, if you have a graph, or if you have 2 points, you can easily draw a line between those 2 points. Hopefully it's a little bit straighter than mine. But how in the world would I find the slope between these two points, aka the line? How would you find the slope? What is the slope again? It's just a fancy rate of change between the y's and the x's. So if I'm trying to find the change in y, well, what does y represent? It's going up, down, left, or right? Up and down. So in order to find the slope of a graph, you literally just have to count how much up you go to find the change in y and how much over you go. This is what is called a slope triangle. A slope triangle is literally there just to help you pretty much count how much up and over you're going. So keep in mind that if you're finding the difference, what mathematical operation are you doing? Subtraction. So this would be y2, y1. Of course, you could count, you could subtract, and do whatever your heart desires as long as you find how tall the slope triangle is. How wide it is the difference between your x's because it's in the x direction, which is just x2 minus y1. So keep in mind that graphs are kind of nice because you just got to be able to count. Count how much up, how much over. Your slope would be the average change in the y over the x's, which brings me to my equation. If you have an equation, it's the same thing. Now, I don't know why, but math is slope is denoted with an M. I'm not sure why they chose an M, but for some reason they always choose slope with an M. And just like before, if you have 2 points, well, how do you find the slope? It's the average change between your y, and I'm going to show change with the triangle y, divided by the change in your x. So that's a y, by the way. How do you find the change? Just like we said, you subtract them. y2 minus y1 divided by x2 minus x1. And that is it. If you can do these two skills in different ways, you're going to be golden. Because that's all slope is, right? Average rate of change. You guys ready to try an example? So just to reiterate, doesn't really matter which one you call your x1 and y1s and your x2s and y2s, as long as you call one of them 1s and the other ones 2. And now you could use your formula, because if you remember, the way you find the slope, the average rate of change between the y's and the x's, is by finding the change in the y's, aka the difference, the subtraction of the y's, divided by the x's. Now, this is what I like to do. I always like to set up my formula where, like, okay, I know I'm going to subtract the y's, I know I'm going to subtract the x's, so I'm just going to set up my fraction. I know my y is going to be on top, my x is going to be at the bottom, and then I go and look for them. Now, this is my y1, this is my y2. Notice that my y2, I'll even change color so that way you can see it, is -2. My y1 is a +4. Now I'm going to look for my x1, y1, or x2, y1. My x2 is right over here, which is a +1. And then my x1 is a -1. So setup is half the battle. Second of it is just kind of simplifying. Now, again, if you call these your 2s and these ones your 1s, it's going to flip things around, but you still get the same answer. Your negatives will just be a little bit different. Again, I like to just call the first ones that show up 1s, second ones that show up 2s, just because it just makes a little more sense to me. And now you just have to figure out the math. What is -2 divided by, or -2 minus 4? -6, right? Now notice that you are managing a negative. So when you have a negative, negative turns into a positive. So 1 plus 2 is 1 plus 1 is 2. -6 divided by 2 is a -3. So you'll notice that if you flip these around, as long as you flip them around correctly, you still got that -3. Okay, right? Because I'm assuming you got the same thing too. Yeah, which is completely okay, whatever you feel comfortable with. Now let's say that you don't want to really deal with it. You just want to graph it. Now let's go ahead and plot those 2 points. So -1 and 4, well, here's -1, here's 4, 1, 2, 3, 4. It'll be located right there. 1 and -2 could be located right over here. And then notice that my line would be through that point. Now, if I wanted to, I didn't have to do the algebraic. All I have to do is be able to count on what is going on. So remember, in order to find the slope of a graph, you just need to count how much up or down it's going and divided by how much over it's going. So is this one going up or down? Yep, down 3. Notice I'm even marking it, so I'm going to mark it with a -3 because down means negative. Over 1. Down 3. Over 1. So notice that these two are in agreement with each other. If I'm trying to take the slope, again, remember, it's the change in the y over the change in the x. So it's -3 over 1. You have to reduce your fractions if they're reducible. -3 divided by 1 is -3. So your slope is -3. Notice that you get the same answer. You need to know both. Okay. All right, so I'll let you guys make sure that you try number 2 on your own. I'll be walking around, seeing if I can help or clarify. All right, so just because for lack of space, I'm going to go ahead and erase this. So I asked you guys to find the slope and also graph them. My hope was that hopefully when you find your slope algebraically, you see that it agrees with your graph. So what you're really doing is that you're understanding slope between two different representations. One is mathematically with numbers, and the other one is graphically. So if you notice, this one is pretty much the same thing. You have 2 points. It's your job to find the slope. Now remember my hint. I always like to set up my slope. If I have 2 points and I know I'm finding the slope of, I always draw my little fraction. I put my minuses over them, and then I look for my y1, my x2s, and all my x's and y's and all that good stuff. So what I do, just to help me out, is I always circle my second numbers that show up in my ordered pair because those are my y's. I need all the help I can, so those visual circles always help me. Now notice on my y2, the second one that showed up was a 5. The first one that showed up in terms of y's is a -3. And then I can go back and look for my x's, which are the uncircled ones, which are 3 and 1. So just like that, you can see that I have a little math to do. In the numerator, I have a negative and negative, which converts to a positive. 5 plus 3 is 8. 8 minus 1 is 2. Finally, 8 divided by 2 is 4. So I can see that my slope is a +4. Now, when I draw these 2 points, what should be my slope? Should be 4. That means I should be going up 4 because it's positive over 1. Up 4 over 1. Let's double check. Here is 1 and -3, which is located right about there. 3 and 5, 1, 2, 3, 2, 3, 4, 5 is right there. So let's see if this checks out. If I go up 4, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1, it checks out. So I'm gonna go ahead and draw my line to kind of just, make sure I got that. Up 4, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. Of course, it helps if you're a little more precise than I am. Really hard with them. All right, so before we go on, let's kind of remind ourselves what the slope can really tell us without even graphing. Notice that I have a negative number and a positive number that represents my slope. When you have a negative number, where's this? What's the shape of the slope? What would you describe that as? Like the movement, is it going up? Is it going down? What's going on with it? It's going down. Now, when your slope is positive, what is happening? Going up, absolutely right. So if you know your slope from the start, you could actually tell the general shape of your graph already. We know we're dealing with linear lines, so they're going to be straight lines. If your slope is positive, is it going to rise or is it going to fall? Rise, right? Because it's going positive. It's going up a positive amount and over. What if it's negative? Yep, because the change in y over change of x, the change in y is going down. Now this is where it gets a little tricky. What if your slope is 0? What does that mean? Stays the same. So what is that going to look like? It would go horizontal because notice that there is 0 change. It's not going up and over anything. It's just going over, and over. How about if you have an undefined slope? Yeah, because notice that there's no way that you could tell how much up it's going because it's going infinitely up. It's undefined. There's no way that you can describe that. This would be a slope of 0 because it's going 0 up. That makes sense. Cool. All right, let me see if I could kind of just make sure to drive this home. I'm gonna try to give you these 2 example problems, and let's see if you got them. If I asked you guys to graph the line passing through the point with a given slope, well, again, slope is just a movement. You can't really graph a movement, at least at this point. But you can start off with a point. Now that point is 3, 2. So 3, 2 is located in the x direction, 3, 1, 2, 3, then up 2, which could be located right over here. Now that I've located my point, I could use the slope to help me draw my line. Now notice that over here, I'm gonna write it bigger, 3 over 2. That is the slope. That's the average rate of change between the y's over the x's. So what I like to do again is to provide me a little bit of a visual. I like to kind of remind myself, okay, change of y over change of x. What is my change in y for 3/2? 3. Now, is that a positive or negative? Positive. So if I'm thinking of the y direction going up and down, am I going to go up or down? You're going to go up. So I'm going to go up 3, 1, 2, 3, and then I'm going to go over 2 in the x direction. X direction is left and right. It's right if it's positive. So 1, 2, my point can be located there. Keep in mind that you can really keep your slope going as much as you want, but you only really need 2 points. Now, just to make sure that you guys kind of understand my direction, I'm gonna go up one more, or up 3 one more time, and then over 2. 1, 2, 3, over 2. My point would be right there. Helps me draw my line a little bit better. All right, let's look at this one right over here. -2/3. My point is -1 and 3. Here's -1. Here's 3. Now this one's a little bit tricky because notice your slope is -2/3. The negative you notice is out in the middle of the fraction. Now, where does this mean? Is my negative in the y? Is it in the x's? Where's it at? What do you guys think? Top or bottom? You have a 50% chance of getting it right. What do you guys think? Where's it at? The bottom? Anybody want to guess the top? Top. Tell you the truth, it's up to you. Doesn't really matter as long as you put it in one direction. Because remember, 2 divided by 3 has to equal negative. That means that 1 and only 1 has to be negative. Now it depends on what is more helpful for you or what is more useful for you. I like to put my negative on top because it's easier for me to understand that a negative means to go down. If I put the negative in the denominator, then that's telling me to go to the left. It feels a little unnatural, especially with graphing. So my suggestion going forward is to always put that negative on top. If it's out on the fraction like we have here, just put it out on top because it's really, really simple for students to be like, okay, negative just means you're going down. It's a lot more easier, what I've noticed through my experience. So I'm going to use this point and the slope to draw my line. Again, what is my change in y? -2. Is that going to go up or down if I'm talking about y? Down 2. So 1, 2 over 3. 1, 2, 3 can be located right there. That's it. Okay. All right. Now you notice you have whole numbers. Dang it, there's no rise and no run. There's nothing underneath it than like these fractions where I can see the change in the y over change of x. What do I do if I have a whole number? What can I do to visually help me? Yeah, remember, you can always put any number over 1 and not change the value. When you divide by 1, you're left with itself. So try these other 2 examples here on your guys' own. Notice it's 5 over something. Now you can see your rise and your run. What I would do. So the first thing is, I have to graph a line through that point and with that following slope. So here's my x and y axis. The first thing I'm going to do is locate my point, -1 and 3. So I know -1 is going to be in the x direction right over there. Then I'm going to go down 3 because notice that my point there is a -3. 1, 2, 3. So here's my point, -1 and -3. Now I have to use my slope. Now notice that this is a whole number, so I'm going to put it over 1 so I can visually see the change in y over the change of x. The change in y is 5, so I mean I'm going to go up 5 over 1. So up 1, 2, 3, 4, 5 over 1. So notice if I go over 1, I'd be located right over there. I know it's hard without graph paper, but if you take your time, just count your little tick marks. Don't spend too much time drawing them out. You're going to be just fine. Let's go ahead and see what that looks like with number 4. My point 4, -2. Here is 1, 2, 3, 4. -2 can be located right down here. Using the slope, -3 and 1, I'm going to put it over 1. Now that negative, does that mean it's going up or down? Yeah, so I'm going to go down 1, 2, 3 over 1, which is located right over here. And that's it. Anybody have any questions? Anything I can help you with? Remember, your retake is tomorrow. There is no homework today. I'm going to post this on the screen. And have a great day. Make sure you sanitize your desks, or I'll do that.